And welcome, Mindsetters, to this session of Learn Extra Live, looking at science. Yeah, I'm Ty, and I've got Tracy here with me. We're going to be going through the lesson, so tell us what's happening.
Today we're going to do mole calculations. Last week they did the concept of the mole with Phil. I know he did a very, very thorough job. So today we get to do the fun part. I'm going to revise a little bit and then do calculations, and we're going to do maths, and it's going to feel a little bit like grade 2 maths, I think, but it's cool. It's lots of fun.
All right,
Yeah.
so on that note, while Tracy goes across there, I'm going to tell you, Mindsetters, make sure you get on the page. Get talking to me, chat to me, let me know what you guys are thinking. If you need help, if you're lost anywhere, make sure you post on the page so I can get those questions and requests from here all the way to Tracy, who's just standing over there. But on that note also, guys, you know the drill. Best post gets these awesome prizes. I've got this Casio calculator to look giveaway and this awesome labeler. And on that note, also, I want to send a quick shout out to Liberty. Thank you for sponsoring the show. And on that note, that's when I hand over to Tracy. Tracy, take it away.
Oh, thank you, Ty. Well, guys, we are carrying on with the mole. You did this last week with Phil. You did some introduction to it. I saw part of it, and I know Phil did a really, really good job. So we're just going to do a little bit of revision, and then we're going to get into calculations. And I'm really hoping, for example, that my kids are watching, because we actually did this today in class. We did some of this, so this is good revision for them. We should all be at this point. Now, just to remind you, here's my little mole in the corner, by the way. He's just a happy mole, and that's not what we're talking about. You realize it's not the little furry creature that goes under the ground. But what is the mole? Well, the mole is a way for us to represent a certain value of atoms or particles or ions or molecules put together, okay? Because remember, we can talk about a dozen, and we all know that we mean 12. If we talk about a century, we mean 100. If we talk about a decade, we mean 10. So we know what those values mean. So if I say I have a dozen people, then we know we have 12 people. If we have a dozen chairs, we have 12 chairs. We all understand those. Now, a mole, as random as it sounds, isn't actually as random as, oh, let's just pick out a number and here we go. Its value is 6,022 times 10 to the 23. We only use 6,002. All right, it's named after this man, Amida Avogadro, who, quite frankly, in my opinion, looks a little bit like a mole. And he first realized in 1811, right, you're talking 200 years ago, that this number needed to exist, that there was a relationship between the mass of an atom, well, the mass of atoms and the number of atoms in a certain quantity. He never quite got to 6,002 times 10 to the 23, didn't really have the equipment, but when they did find that number, they did give him the honor and name it after him. So it's known as Avogadro's number, okay? So it's named after him, even though he never really found it. And just to give you an idea of how big this value is, if you had to take marshmallows, because that's what we do, and you had to put them across the entire United States, okay, in flat over the United States, it would reach, I'm trying to get this right, 900 kilometers into the air, okay? If you had to take this amount of paper and put it over the state of California in 1 million piles of paper across the state of California, it would reach beyond the sun. Just, that's how big this number is.
Wow.
Yeah. And if a computer could count at 1 million numbers per second, it would take a computer over 1 billion years to count to this number. Just, it's how big it is. And yet, you can hold Avogadro's number of atoms in your hand, because that's how small molecules and atoms are. Just to give you an idea of what we mean by that, okay? Now, be nice. There we go. So, the mole is an amount of substance that contains as many formula units as there are atoms in 12 grams of carbon-12. Remember, grade 10s, we used to compare mass and all that sort of stuff to hydrogen, because hydrogen was the lightest known element. It stopped being hydrogen when carbon became more prevalent, and also carbon is our most abundant element. It's found in so many things, and it's also very, very inert. So it's easy for us to compare it to. Now, it's carbon-12, be very careful here. Carbon-12 and not carbon-14. Remember, we have isotopes. Phil definitely dealt with this last week. Isotopes, carbon-12 and 14. 14's got extra neutrons. Carbon-12 is the more abundant one, so we use carbon-12. 1 mole of any substance contains 6,02 times 10 to the 23 particles, elementary particles. Elementary particles, grade 10s, electrons, ions, atoms, molecules, formula units. Formula units are what we use for ionic substances like sodium chloride, NaCl. So, a mole of an element has a mass equal to the atomic mass. The masses of 1 mole of a compound is equal to its formula mass in grams. You have to have a periodic table. Hopefully there's one in your textbooks, okay? If not, ask your teachers to give you one, because you cannot do this section of work without a periodic table. You should have worked with a periodic table before now and realized that you can find atomic mass on the periodic table. It's not something you have to learn, grade 10s. You're not expected to know that hydrogen's atomic mass is 1,01, or that sulfur's atomic mass is 32,1 grams. The only reason why I would know something like that is because I've been teaching for a long time and I use it all the time, okay? So every year I teach it to more than one grade. Every year I do it over and over again. So I've learned it as it goes along, but we don't expect you to know those masses. It's not one of those things you need to know. So be careful if anyone says to you, you have to, because you don't, okay? It's on your periodic table. Make sure you know where to find it. Okay, so now we get on to what molar mass is. The mass of a mole of atoms is the element's relative atomic mass given in grams. Relative atomic mass, relative molar mass, relative molecular mass, any of those terms means we're comparing the mass to carbon, and the value is the same as the mass number on the periodic table without any units. Once we start getting into molar mass, and it's whether it's molar molecular mass, atomic mass, now we get to the point where we need to use our units, okay? New units, grams per mole, okay? Grams per mole, mole to the minus 1. So for example, sulfur, I took this 32 off an old periodic table. It's the one the current grade 11s and 12s are using. Yours is slightly different, grade 10s, according to the new CAPS document. And on that periodic table, it's on the old one, it's 32 grams per mole, but actually on the new one, and I was actually hoping to get one for you, but unfortunately it didn't come through on time, or didn't sync from my computer, and I do apologize for that, is you have one that looks a little bit like this, and they've actually changed it, and on this periodic table, they're saying that the molar mass of sulfur is 32,1 grams per mole. Now, essentially, grade 10s, for now, it doesn't really matter. If you guys have got one of the older periodic tables and you're now doing these calculations with me, which is I'd really like you to do, and your numbers are slightly different to the one I'm using, because I'm going to use the new periodic table, please don't stress about it, grade 10s. What I'm more concerned about, more than anything else today, is that you understand the concepts and you can do the maths. Okay, that's far more important than whether you're using comma 1 or comma 01, as the case may be. Okay, oxygen, molar mass is actually 16 on the new periodic table as well. So I say 2 times 16 because there's 2 oxygen atoms in an oxygen molecule. So that's nice and simple. When we get to water, water's H2O, 2 hydrogens. Each hydrogen is 1, though on the new periodic table it's 1,01. So I would then write it out like this. So we have H2O, 2 times 1,01, plus 16, and that's actually going to give me 18,02. Really makes very little difference at this point in time. The reason why your old periodic tables had was the way it was is we really were trying to make your life a little bit easier. Round them off to whole numbers makes calculations easier. Also makes it easier for us when we're trying to devise questions, so that we don't have to worry too much about whole numbers and all sorts of things. But hey, we want to make sure your science is relevant. We want to make sure that when you get to varsity, if you carry on with science, that there's not too much of a big jump between the two. Okay, hopefully I haven't lost any of you just yet. So, the mole concept, I just went backwards. There we go. Atomic mass. Carbon-12 is used as a standard. I've spoken to you about this. The mass number on the periodic table shows the value of the atomic mass. Always look at the key on your periodic table. Please be careful. If you had to Google periodic table on your computer at home, you'll find hundreds of different periodic tables. They all show different values, but they all have to have a key. There's no set way in saying, well, when you write the periodic table, you must have the mass number in this position, and you must have the atomic number. Not at all. The only thing that's set, actually, is the way it looks. Okay, remember that was set by Dmitri Mendeleev, and that's been set since the 1870s, 1880s. So it's been set for a very, 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 very long time. Okay, and that man was actually a genius when it came to this. Relative atomic mass, I spoke to you about this earlier. Relative atomic mass is only a value, but please be careful here. We use the symbol AR. Okay, relative atomic mass, A for atomic mass, little r because it's relative. Okay, we're comparing it to something. Because it's a comparison, we do not use units. Okay, so for example, sodium's relative atomic mass is 23. Not 23 grams, not 23 units, not 23 grams per mole. It's 23, period. Okay, next. And I went backwards again. Molar mass. Molar mass, not relative anymore. Molar mass, grams per mole. Okay? We also will indicate molar mass by a capital M. No little r anymore because we're not comparing it to anything, grade 10s. Okay? It's just a capital M. Once again, we get it off the periodic table. Relative molar mass, it is a comparison like relative atomic mass, and you would indicate relative molar mass with a little r. Okay, it's not an A. Molar mass indicates that I really am looking at molecules more than atoms. It is only a value, no units. So important that you get that. It's not always that useful for us because the actual molar mass is far more useful for us. Okay, and I'll get back to that in a second. There we go. Now we get to the fun part. Now we get to the calculations. First one, the number of moles of any substance is equal to the mass we're given divided by the molar mass. Think of it this way. If I want to know how many dozen eggs I have, I need to take the number of eggs I have divided by 12, because 12 represents 1 dozen. Okay, so I would do the same here. I'm going to take the mass of the sample, however much I've got of a certain sample, and divide by the mass that represents 1 mole. Very important here, grade 10s. You can have half a mole, you could have a quarter of a mole, you could have a millionth of a mole. It goes down to 10 to the 23, but you cannot have half an electron. You can't have half a particle. So watch your numbers very, 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 very carefully once you work out number of particles, okay? It can't be a fraction. So in other words, you can't get number of particles less than 1. So you can't have half a particle. You can have 0.5 times 10 to the 30. Of course you can, because the 30 then pushes the decimal point to the right, and that's actually 5 with 29 noughts behind it. That's a whole number. That's fine. Okay, so be careful here. Please be careful as well with your units. It's one of the ones we get very confused with because it's called number of moles with M-O-L-E-S, and then the unit is mole, M-O-L. Be careful. Mass, grams per mole. Okay, grade 10s, this is something you need to take note of just as a bit of a exam thing. In chemistry, we measure mass in grams, but in physics, we measure mass in kilograms. Because in physics, we're definitely more involved in a macroscopic environment, whereas in chemistry, we're looking at microscope, the things that are very, very, very tiny. So we measure in grams. Then, and this, my grade 10s in particular didn't like, because sometimes they can be a little lazy, and yes, I'm talking to some of them, they know who I'm talking to. Okay. Number of moles is the number of particles divided by Avogadro's number. There is no, no, that's not what I wanted. There is no abbreviation for number of particles. You write out number of particles. because there's no abbreviation for that, no symbol. Do not make one up, because we're not in your head. We don't know what's going on in there, which would be a little scary, I think, if we did sometimes.
Yes.
Let's be honest. Okay.
That would be.
Particularly in the ones I teach. There's definitely moments. Yeah, I'm having they didn't, we didn't have a happy day today, so
Aw.
it's okay, I can pick on them. It's okay. They know. I do this with them. Anyway, so number of particles divided by Avogadro's number, 6,02 times 10 to the 23. And yes, you will be given that on your information sheets. Okay, so stop stressing about it. But you must make sure you get to use this correctly. Okay, and Ty, I think, because there's been a little bit of information overload, I think it's a good place to go to a break.
Okay.
And then when we come back, I'll do some calculations with them.
All right, that's
Good
no
place.
problem. On that note, as I said, mindset is keep the page active. Always just get there, post what you guys are thinking, post if you're worried, if you think you're lost in anything, just let me know so I can get those questions to Tracy and then she can answer them for you. But on that note, mindsetters, do not disappear. We'll see you after this break. And welcome back, mindsetters. Hope you had a nice little break and you made sure that you have your pens and pads out and you're ready to make notes. And with strong advisement, make sure you guys get a blanket and something warm, because yes, I'm sure you guys have noticed that it has been snowing outside. But regardless, doesn't mean now you go outside and play in the snow, because it's actually really cold and not that fun. Movies lie. But anyway, on that note, make sure you're paying attention right now, because I'm going to hand you over to Tracy, who's going to continue. Tracy, take it away.
Thank you. And also, if they wait 45 minutes and then go out to play in the snow, there's more snow to play with.
True.
Then you can make bigger snowmen.
True that.
And then it's dark. And then it's called, stay indoors. Seriously. I'm with Ty on this one. It's not as much fun as it looks. Okay.
Movies lie.
They do. It's freaking cold. And then your hands get... Never mind. Moving on. Okay. I suppose I could have put something in about calculating the molar mass of snow. But it is just water, after all.
Yes. Frozen.
Frozen. Yeah, let's not go there.
Yeah.
Anyway. So... we're now going to do some calculations, okay? So now we're looking at a couple of things. I have a periodic table, so that's what we can use as reference. And just so you know, this is not, well, these are my cheat notes, but we're good, but we're not that good. So first thing is they want us to calculate number of moles. So the question is, what is N? Okay, number of moles. So we look at what we're given, and number of moles is mass divided by molar mass. So we go, okay, in each of these cases, I'm given mass. I'm given how much of the sample we have, which means we need to work out the molar mass if it's relevant. The nice thing